In this video, I'll explain about the basic concepts of torques. So torque is nothing but, we have learned the equation force into perpendicular distance. I'll explain it. Let's say you are going to open a door. This is, you are having handle here, and this is the pivot about which the door is rotated. So door will be having different position like this. Just imagine someone is applying a force at the extreme position. So that is person 1. Another person is applying the force at this position, person number 2. Another person is applying a force at this position, but in an inclined direction, point number 3. Now one person is applying a force in this direction, point number 4, person number 4. Just visualize, you will be knowing that a person, when he is applying at the extreme point, which is away from the point of rotation or the axis of rotation, will be able to make the motion with lesser effort. So this happens due to his higher amount of torque when he is applying the same force that is applied by all other persons. Now, along with that, you can visualize if this is the door, if someone is applying a force in this direction, whatever may be the force, that will not result in rotation. So basically, it's not only force that makes the motion, it's force and applied in which length away, in what distance, which is far away from the point of rotation, and that also affects the torque which is the torque which you are exerting on the door will also be affected when the angle of application of the force changes. I'll explain it. Let's say this is the door. You are applying the force in this direction. As the torque has defined as force into perpendicular distance. Now force, you have to find the line of action of force. This is the line of action of the force. Now this is the perpendicular distance. So I can say torque by the first person is F1 into the length, the total length L1. So this is the maximum length possible. And now I will take an example where he is applying the force in this direction. The same force he is applying. Now the line of action of the force become this. Now how will you be drawing the perpendicular to the line of action of force? This is the perpendicular. Now see, torque by the second person in this example is nothing but F2 into, or the same force F1. We'll assume that he has applied the same force, but one in this direction and one in this direction, into this length, that is nothing but L2. See, now it's the same force, but the length, perpendicular distance to the line of action of force has got changed. Now just see, if this is the total length L, and if this angle is theta, that is this, he has applied at an angle theta with the door. If this angle is theta, if this is L, then we know that this will be L cos theta, this will be L sin theta. Or just take sin theta. What is sin theta? Opposite by hypotenuse, that is L2 divided by L, or L2 is nothing but L cos theta. So if this is L2 is nothing but L sin theta. Just multiply L sin theta, you'll be getting L2. Just multiply here F1 into L sin theta. Have you ever learned this equation, that is a vector into another vector, or basically the modulus of one vector into modulus of another vector into sin theta? What is this? This is nothing but cross product. Here in this case, that will be L cross F. That is nothing but modulus of L into modulus of F into sin theta, and we will be having an n cap. because torque is a vector quantity. So if you are just representing it as LF sin theta, L is basically modulus of L, that will be obviously a value, a magnitude. This will also be a magnitude. This is again a magnitude. To make this a vector quantity, you should be given with some additional quantity here that will be explaining the direction to make it a vector. So that is nothing but L cross F, LF sin theta. Torque is equal to L cross F, or if you are taking the position vector as R, then that will be R cross F. This is an important derivation. Similarly, or I can say in words, that is torque is nothing but moment of, R cross is nothing but moment of force. So torque is defined as moment of force or moment of linear force. Now I'll explain about angular momentum. Angular momentum is nothing but moment of linear moment. So moment of is nothing but R cross, linear moment is nothing but mv, p. This is angular momentum. Nothing but, if you have a mass which is going in a particular direction, which is moving, for example this is the pivot and this mass is going in some direction, let's say it's going in this direction, mv. Now how will you be finding the angular momentum with respect to this point? So just draw the line of angular momentum or direction of angular momentum. Just get the perpendicular distance to that. That is nothing but, if this is R, then we know that this will be R sin theta. Having this as theta, just take sin theta is equal to, if this is some value which we need to find x, then sin theta is nothing but opposite divided by hypotenuse R. So x is nothing but R sin theta itself. So R sin theta will be the perpendicular distance. So R sin theta into mv, R sin theta into mv will be the moment of linear momentum, which is angular momentum. So what is mv R sin theta? That is nothing but, mv is nothing but momentum, which is a vector. So R sin theta into momentum. So p R sin theta or rp sin theta is nothing but R cross p. R cross p is simply mod R mod p sin theta. So this is linear momentum. We have learned many equations to find moment of inertia. Now where we will be applying the moment of inertia. So wherever the case you are applying mass, or wherever the case you are using the concept mass in linear motion, for example that is nothing but translational motion. For example, F is equal to ma, and another example P is equal to mv. Then which are the equations? Half kinetic energy is equal to half mv square. Wherever you are seeing mass in linear motion, in linear equation, not linear equation, equations for translational motion, you can convert those equations into rotational motion by changing the mass into moment of inertia. Along with that, this quantity also has to be changed. So what is the rotational analogy of force? That is torque. For mass, it is moment of inertia. For acceleration, that is angular acceleration. For p is equal to mv, momentum. This is linear momentum, this will be angular momentum. I for velocity omega. For kinetic energy ke, that will be same energy itself. Half, this will be kinetic energy associated with rotational motion, this is associated with linear motion. So half into mass is moment of inertia here, omega square. And along with that you can take you can derive many other equations, which is about power is equal to force into velocity. Here the same power associated with rotational motion is equal to, instead of force, that is torque, into, instead of velocity, that is angular velocity.